Okay, so 12, 13, 14 do together. These are about chi-square values, pretty much reading the chi-square distribution table. So 12, the critical chi-square value for 15 degrees of freedom when alpha equals 0.05 and the test is right-tailed is. Okay, now the chi-square distribution is a positively skewed distribution. Let me draw it properly. I don't want to draw it like I've been drawing so many normal distributions. It almost feels like it's going to be normal. So there's a chi-square distribution. General shape. It's positively skewed. And when you look at the table, this is the chi-squared value it gives you. It gives you the chi-squared value that represents that area to the right, that probability to the right, that area to the right. So if I'm looking at 0.05, this area here will be 0.05. And the table is going to give me that chi-squared value, that chi-squared critical value for that situation. So let's go to the table. 15 degrees of freedom, 0.05. It's the last one. The last one. See, look, see the area, alpha, to the right there. So it has the degrees of freedom on the left, on the first column, and then that top row is the alpha value. So 0.05, I believe it was 13 degrees of freedom, 15 degrees of freedom. 15 degrees of freedom here, 0.05, that looks like 24.996. 24.996. 24.996. Same thing with the next. Find the alpha equals 0.01 critical value for the chi-square statistic with 12 degrees of freedom. 12 degrees of freedom, 0.01. 12 degrees of freedom, it's 0.01 all the way at the end here. 12 degrees of freedom, 0.01. 26.217. Now, find the area to the right of 2.603. So now for number 14, we're saying 2.603 is my chi-squared value, and I want to know what the area to the right of that is with 11 degrees of freedom. So I'm looking for this number in the body of the distribution. 11 degrees of freedom, 2.603. Right there it is. 11 degrees of freedom, 2.603. That's 0.995. That's what alpha is, 0.995. That's the area to the right. So that's all the way over here, right? That chi-squared value. Yep,